is Professor Pelton. This is Algebra 2, Chapter 7, Section 3 on multiplying and dividing rational expressions. Before we go on to dividing, we need to review factoring perfect cubes, basically. So there's factoring cubes and there's perfect cubes. These are the perfect cubes. So if you have two terms that are perfect cubes, these are the rules that apply, where A and B are perfect cubes. Okay. Or being cubed. So the base terms need to be cubes. So you have the sum rule and the difference rule. So based on whether it's a sum or a difference, you have to apply the one that fits the problem. So you have the sum rule and the difference rule. So the first one we have here is a difference, right? Because it's a subtraction of 64x cubed minus 125, but they're not both the third power. But 64 and 125 are cubic numbers. So 64x cubed is shoot, not 2, sorry. So that's 4x to the third minus 5 to the third equals 0 if I rewrite that, because again, they're both cubic numbers. So that means A is 4x and B is 5, right? Because A and B are the base numbers. It needs to be something that's cubic, which they are, to get the final or the original problem back. So I need to use that, and I need to use the difference rule, okay? So what I have here is A minus B in the first part, which would be 4x minus 5. Then it says A squared, so that's going to be 4x squared, which is incorrect because you have to do both. So what you should do is on the trinomial part, put brackets, plus AB, so that's 4x times 5, plus b squared, so that is the 5 squared. So simplified equals 0. 4x minus 5 times 16x squared plus 20x plus 25 equals 0. And you could solve each piece individually. The 4x minus 5 will give you a rational answer, and the trinomial 16x squared plus 20x plus 25 will need to be done with quadratic formula, and that will give you two imaginary solutions. Okay, but that's all we need for what we're going to be doing next. All right, pause the video, try the student problem. Okay, so in this case, 2x to the third makes a equal to 2x, because we need a cubic number, plus 1 to the third. So b is just 1 in this case. So now we're applying the sum rule because it's the sum of two cubes. So that rule is going to give us 2x plus 1, because the rule says a plus b. And then we'll do our bracket. A squared minus a times b. Whoops, that didn't work out too well. Okay, plus b squared. So we have 2x plus 1 times 4x squared minus 2x plus 1. And you can solve each piece individually now. The 2x plus 1 will give you a negative 1/2 answer, which is rational. And the 4x squared minus 2x plus 1 will be quadratic formula, which will give you two imaginary solutions. Okay, so let's look at something now that's algebra 2 for rational, which is what we're actually doing with polynomials. Okay. All right. So let's say we have a multiplying here. This is really over 1. Okay. So what you really have here is x plus 5 times x squared plus x plus 1. Okay. Let me change that plus a little bit better here. All right, so on the bottom, we just have a 1, which we can basically ignore, but we have a cubic term, which is 1x cubed minus 1 cubed. So a is 1x and b is 1. So do the perfect cube rule for a difference of two cubes. So that is a minus b, okay, a squared plus a times b plus b squared, okay? So now you have very similar factors if you look at it. So you really have x plus 5 and x squared plus x plus 1 over x minus 1, x squared plus x plus 1, which cancel, leaving us with a final term of x plus 5 over x minus 1, okay, where x cannot equal 1 because of the x minus 1 denominator. And you're probably saying to yourself, what about the trinomial x squared plus 1x plus 1? Well, that gives you two imaginary solutions. You don't have to worry about those. We only worry about what the real numbers of the domain that it can't be. All right, pause the video. Try the student problem for yourself. Okay, so again, this is really over 1 if you think about it. So this is x plus 2 and x squared plus 3x plus 9. Okay, so on the bottom, we can ignore the 1 because 1 times anything is itself, but we have a perfect cube difference here. So this is x cubed minus 3 cubed. Okay, so a is x and b is 3. So if I do the difference rule, it's a minus b, a squared, plus, my x got messed up there, a times b plus b squared. Okay, because that's a 3. That came out very 3. So if I elongate that out, I get x plus 2, x squared plus 3x plus 9 over x minus 3, x squared plus 3x plus 9, which cancels, leaving you with x plus 2 over x minus 3 is our final expression, where x cannot equal just positive 3. And again, you're saying to yourself, what about the trinomial term? Well, the trinomial term of x squared plus 3x plus 9 does not give you any real solutions if you try to factor it out. Okay, you can plug it into quadratic form if you want to verify, but the only real answer that you can't plug in for x, which we care about as a real domain, is the positive 3 as the end of part 3.